Okay, welcome to part 3 of this video. Hopefully there aren't too many parts after this, because I'm getting tired. But, yeah, the first few takes had some difficulty because my camera ran out of memory. And I had already done the work for some of these problems, so we're just going to walk through the work. And if you're still here watching these videos, I'm going to say you're either really dedicated, or you have nothing better to do with your time. So, let's begin. So, question 10, this is the problem where they give you this vector, u, and the vector v, and they say u is equal to vector from a to b, and v is vector from m to n, and they give you these 2 points. A is negative 7, 3, b is negative 3, 7, and they want you to find the value of this constant k that's going to make u equal to v. So in order to do that, you find the component form of the two vectors. So you take the initial point, which is negative 7, 3, and you subtract it from the terminal point, negative 3, 7, right? So negative 3, 7 minus negative 7, 3 becomes 4, 4. Okay? So 4, 4 is AB. And then you do the same thing where you have k as a terminal point, so you're going to subtract the initial point m from n, and you do k minus 7, which is k plus 7, right? So k plus 7, and then negative 1 plus 5 is 4. And then to have these two equal, the component forms have to be equal. So the y's are already equal, where 4, 4, and k plus 7, comma 4. In order for these to be equal, both parts have to be equal, and these y's are both 4's, so they're already equal, and k plus 7 has to equal 4. So k plus 7 is 4, and you subtract 7, and you get k equals negative 3. So they give you point E and point F. E is negative 6, 5, F is 1, 11. Subtract initial point from terminal point because you're solving for vector EF. 1, 11 minus negative 6, 5 gives you the vector 7, 6. Then they want you to graph it. They give you a coordinate plane to use, which is better than mine. Mine is hand-drawn. So you do 7 in the x direction and positive 7, and 6 up, and you get to this point. You draw a vector, and you can say that that's EF. And that's all you have to do with that one, I think. Yeah. Then 12. 12 is probably one of the trickier ones on this whole thing, where you have a vector v in component form negative 10, comma 1. I'm just going to draw this little line here and show this is 12. So negative 10, 1. Then you're given that the magnitude of u is 1/3 of the magnitude of v. In order to solve this problem, I made the assumption that vector v and vector u follow the same direction. That might or might not be correct. We're going to verify that. But going off that assumption, I'm going to solve the rest of the problem. So magnitude of v is going to be the square root of 10 squared plus 1 squared. That's the distance formula. That's how you find the magnitude of the vector. So 100 plus 1 is 101, so the square root of 101. That'll be the magnitude of v. Now to find the angle of v, you know that the tangent of the angle is going to be b over a, which is the x and y components. So b is negative 1 over a is negative 10. So when you solve that, you can do that by doing the arctangent of both. And when you do the arctangent of both, you get an arctangent of negative 1 over negative 10, which will get you your angle, which is, that's your angle, direction angle of 5.7. But you have to observe this is in the third quadrant because it's negative 10, negative 1. So negative 10, negative 1 falls in here somewhere. Third quadrant, and it's the same angle as the first quadrant, but you have to add 180 so it's in the third quadrant. So you get 185.71. That's your angle. Now for you to follow that angle, u, vector u, we're assuming that it has to follow that angle. And then if you want to find the component form, you have the magnitude and the angle. So the component form is the magnitude, which is 101 divided by 3, times the cosine of the angle, comma the sine of the angle. So then if you plug that into your calculator, which could be a bit tough, but that'll get you the answer of negative 3.33, comma negative 0.33. So now we're going to go on to 13. Let's go camera. So 13, you want to find the vector as a combination of the standard unit vectors I and j. So vector v is equal to ab, and a is negative 3, 0, and b is negative 10, negative 6. Okay, so first find the vector ab. In your component form, you should be used to doing that from these last few problems, but negative 10, negative 6, minus negative 3, 0, because that's terminal minus initial. Negative 10 plus 3 is negative 7. Negative 6 minus 0 is negative 6. So you get that the vector is negative 7, negative 6. Now they want it in the combination of unit vectors I and j. I is simply 1, 0, and j is 0, 1. So really you just replace, you separate these into the sum, and you replace I, you just attach the I to the x value and j to the y value. So negative 7i minus 6 times j. And that's your answer, negative 7i minus 6j. Let's see if we can squeeze one more on this page. So question 14. So find the directional angle of vector v. So vector v is in component form negative 6, negative 3. In order to find the directional angle, well, the directional angle, the tangent of the directional angle is equal to this y value over the x value, negative 3 over negative 6. So to find the angle itself, you do arctangent of 3 over 6 is 1/2, which says that it's 26.57. But again, you have to look for the quadrants. Always look for which quadrant it's in. Negative 6, negative 3 falls in the third quadrant, somewhere over here. And this angle is going to be in the first quadrant. So to get an equivalent angle, you have to add 180 again. So 26.57 plus 180, where did that go? Is 206.57. So 206.57 is your directional angle. Okay. And this camera makes me look black, but okay. 15. So this is a resultant of the magnitude problem. So you're given a horizontal, one vector, then another vector at a different angle, and 24 degrees for this one, with force of 65 pounds, 86 pounds, and 21 degrees below the horizon. And they want you to find the magnitude of the resultant. Direction and magnitude. So everything about it pretty much. So sketch a little parallelogram again, because you're finding, that's how you would find the graphical representation. It looks something like that. Can't be exactly sure where the point is, but it's a little parallelogram. It's not the point. The point is not going to be on the axis, so don't assume that. So let's make it maybe a little below. It's a terrible drawing. Okay, sorry for my terrible drawing. Anyway, but let's find component forms of these two vectors. So you get magnitude and directional angle. So you know that let's call this one U. Call this one V, just for the, you can determine which one is which. So U is going to be the magnitude, which is 65, times cosine of angle, comma sine of angle. So cosine 24, comma sine of 24, which is, where did it go? 59.38, comma 26.44. And So that's what the vector u is equal to in component form, 59.38 and 26.44. Then vector v, if you apply the same formula, is magnitude times cosine of angle times sine of angle. Which produces 80.29 and 30.82, but you have to observe that the y is in the negative this time, so you have to do negative 30.82. Okay. Okay, so to find the component form of the sum of the two, you just add the x parts and the y parts. So that 59.38 plus 80.29, and that'll give you 139.67. And then if you add the y values, 26.44 minus 30, observe that, 0.82, you get negative 4.38. And I did all this on the calculator because it's a waste of time doing it by hand. And on this test, it's going to be really, really important to save time. So 139.67, comma, negative 4.38. That's the vector of u plus v. Or the resultant, which is the sum of the vectors. U plus v is that. So to find the magnitude of that, you do the distance formula again. U plus v is equal to the square root of this squared, 0.67 squared, plus this squared, negative 4 squared. Looks sloppy, but gets the point across. And the magnitude is going to be equal to 139.7, which is really close to the first one, but that's what it is. That's the magnitude, 139.7. Then to find the directional angle, you do the arctangent of the component form, which is negative 4 over this, 4.38 divided by 139.67, which is equal to 1.8 degrees. Well, actually, it equals a really high number, which is close to 365 if you apply this negative, but it becomes negative 1.8 degrees if you add 360. And the only answer choice that corresponds with this 139.7 is the one with 1.8, in case you want to look for that, and that's A. And looks like we're going to run out of time for this video, so hopefully I'll see you in the next one.